Right. Paper 2. First question is given as the following, right? Column A, 4 gram NaOH plus 8.4 gram NaHCO. So 4 gram NaOH, 100 millimoles, and this is also 100 millimoles. And it is reacted to 1 molar HCl. Okay, column B is written. At phenolphthalein endpoint only for NaOH. 50 ml 1 molar. No, you need how much ml? 100 ml. At methyl orange endpoint, after phenolphthalein endpoint 50 ml, that is also false because NaHCO3 100 millimoles. So R is correct and S also correct. So A is R and S. So answer should be A or C. Okay, second option. 2 gram NaOH, 5.3 gram Na2CO3. Na2CO3, 1 mole. What will happen in the presence of phenolphthalein indicator? NaOH fully neutralized, and Na2CO3 neutralized till it will become what will be NaHCO. Okay, so till it become NaHCO. This is fully neutralized. That means Na2CO3 5.3 gram, again 100 millimoles. So this means 100. Are you getting that? 5.3 gram is 50 millimoles. 106 is the this is 50. So this is what happened in the presence of phenolphthalein indicator. This is NaOH 2 gram, 50 millimole. So HCl also 50. That means in the presence of phenolphthalein indicator, the total HCl, what will be 50 plus 50. Okay, so answer what will come? At methyl orange, Q definitely will come because once 50 over, HCl will form 50. To neutralize that 50 NaHCO3, you need what will be? 50 millimole, you need another 50 millimole methyl orange. So Q will come. Phenolphthalein endpoint will be 100. QR. Okay, so QR you have again both sides. So you need to see option C. 10.6 gram Na2CO3, which is 100 millimoles, but phenolphthalein will be need how much? 100 milligrams. Okay, in a ratio 1:2. If 100 means HCl also 100 to become 100 NaHCO3. The remaining 100 need what will be methyl orange. That means R will come, then also S will come. So that way answer A is correct. D you need not see. Okay. Second one. The number of ions of Na plus in 20 ml of 0.4 molar Na3PO4. So it will be how much millimole? Na3PO4. You got 20 ml 0.4. So 20 into 0.4, 8 millimole. And how to ionize Na3PO4? 3 Na plus PO4. So if this is 8, this will be 24. So 24 millimoles of Na plus. So 24 into 6 into 10 power 20. The 24 6 are what?
So it has an NS. So they ask NS, the temper.
So this. So that means 2.4 into 24 into 10 power minus 3 because of millimole. So 2.4 into 10 power minus 2 Na. So A is the answer. 20 ml 1 molar KMnO4 required to oxidize a mixture of 20 ml of 1 molar ferrous oxalate, 10 ml of H2O2 solution. What is the percentage strength of H2O? So 20 ml KMnO4. 20 ml KMnO4. 1 molar. So 2 millimole KMnO4. 2 millimole KMnO4 acidic medium. Each 1 mole gain 5 electrons. 2 millimole. Total 10 millimole electron it will gain. ferrous oxalate is written 2 millimole. Each ferrous oxalate gives what? 3 electrons. So 2 millimole means 6 millimole ferrous oxalate gone. The remaining 4 millimole is taken for H2O2. So 4 millimoles of KMnO4 reacting with H2O2. H2O2 and KMnO4 react 2:5. This 5:2. If this is 4 millimoles of electrons we are talking about. Okay. So 4 each H2O2 we will not go because we have already done electrons. So total 10 millimole electrons KMnO4 gaining. In that 6 millimoles given by which one? Ferrous oxalate. So 4 millimole H2O2 is given. 4 millimoles of electron given by H2O2. You know H2O2 becomes actually O2 by giving 2 electrons. By giving what electrons? 2 electrons. Okay, so in acidic medium, okay, half reaction if you want, we will have 2H plus. Okay. This is the half reaction. Okay. So to get 4 millimole electron, you need what will be 2 millimole H2O2. So 2 millimole H2O2 in 10 ml is there. 2 millimole H2O2 in how much ml? So molarity is 2 by 10. 2 by 10 is what? 0.2 is the molarity. That is 0.2 mole in 1 liter. So in 100 ml, how much is that? 0.02 mole. Okay. So 0.02 mole mass will be what? 0.02 into 34, which is 6.8. It is 0.68. So 0.68 gram per 100 ml. Okay. The calculation mistake was 0.02.
So I think in 10 ml.
No?
In 10 ml.
Okay, overall question is
10 ml.
10 ml H2. So that's okay. 10 ml if you put 2 by 10, what will be? 0.2. So 0.2 molarity. So 0.2 moles in 1 liter. In 100 ml, what will be the point? In 1 liter, 0.2 mole means 100 ml, what will be? 0.02 mole will be. 0.02 into 34, what will be? Check now. So here you go, KMnO4, 2 millimole KMnO4. Oh, that's a mistake. KMnO4 is 20 millimole, 20 ml 1 mole. So 20 millimole KMnO4. So that means 20 into 5, it takes 100 millimole electrons. 100 millimoles of electrons. Ferrous oxalate itself will give 60. Again, ferrous oxalate is written 20 ml 1 mole. Each ferrous oxalate gives what will give? Each ferrous oxalate gives 3 electrons. You know, if 3 also oxidize, oxalate also. So if this is 20 millimoles means electrons will be what? 66. So 100 plus 60 gone means 40. 40 given by H2O2. If this is 40, this is 20 millimoles. So 20 by 10, 2 mole per liter. That means 0.2 mole will be in 100 ml. So mass if we convert 0.2 into 34. So 6.8 gram per. So answer A. 4. Na2C2O3 Cl2 plus H2. NaHSO. Find the equivalent mass of Na2S2. somewhat easy question. So Na2S2O3, sulfur plus 2 become NaHSO4. Sulfur will be plus 6, plus 2 to plus 6. Obviously to balance sulfur 2 you need. Plus 2 to plus 6, the difference is what? 4. So 2 into 4 will be 8. So molecular weight by 8 equals. Fifth one. The volume of concentrated sulfuric acid of specific gravity 1.8 mole, 1.84 containing 98% sulfuric acid by weight required to prepare 200 ml 0.5 n solution. So the final one will be 200 into 0.5. Sulfuric acid normality is given. So normality or molarity? Normality. So molarity means divided by, so this much millimoles should be final. So for that we must know initial molarity, and you take some ml of initial molarity. The same millimole should be there even after making 200 ml by adding extra water, because by diluting millimoles will not change. So the question is B, they are asking. We need to know molarity, initial molarity, stock solution molarity. The volume of sulfuric acid, specific gravity 1.84, containing 98% sulfuric acid. So 98% sulfuric acid means 98 gram sulfuric acid in 100 gram water, 100 gram solution. If 100 gram, 100 ml solution means no need of density. Okay, understood that? 100 gram solution. And we need volume. So 98 gram sulfuric acid, H2SO. 100 by specific gravity is 1.8 gram per ml. So we will make it 100 by 1.84, what will come? Some roughly 55, we can say 55 or 54, that many ml solution. So we can go molarity, initial molarity. Initial molarity is 98 mass by molecular mass also 98 sulfuric acid. So number of moles 1, but volume is what? Liter 0.55 by 1000, because volume should be in liters. Okay, this will be the answer. So that means what is coming? 1000 by 55 by 1000 by 50. So 1000 by 55 what will come approximately? It's initial molarity. 18 of 1, 45, 450. So 18 point some 1. That's the initial molarity. So you got 18.1. We do not know volume. So V can 200 into 0.5. So can you tell 200, 100 by 36 approximately some 2 point something. So best answer D, 2.7. Right, sixth one. 1 gram metallic tin in presence of acidic K2Cr2, so is oxidized to stannate. Find out the volume of decinormal K2Cr2 required. Decinormal. Okay, direct normality they are asking, so you can do it with these words. So 1 gram metallic tin, SN2 plus to SN4 plus. So 1 gram, SN order, its atomic mass will be 180. So these many moles. into 1000, these many millimoles, into 2, these many milliequivalent. Same milliequivalent dichromate needed, and they are asking what's the normality? Decinormal, 0.1 normal. So you can find volume. So volume is going to be 500 by 11.8. Sorry, 2000 by 0.1 will become 11.8. That much volume is volume in ml. Because this is milliequivalence. So 2000 by 11.8, what will be approximately? 168. It's the nearest. So C is the answer. Seventh question. Chromium not found in +6 oxidation state in K3CrO8. K3CrO8 is a coordination compound. Actually, it should be written in the class I have discussed. Each one is a peroxide. So 3 plus chromium minus 8 equal to 2. Each O2 peroxide, O2 2 minus. So you will get chromium will be +5. Next, 0.98 gram polybasic acid, polychloride 98, requires 30 ml of 0.5 molar barium hydroxide for complete neutralization. Find the basicity of the acid. So 0.98 gram polybasic acid. Let's say it's N-replaceable hydrogen. Okay. It's reacting with BaOH twice. So ratio will be BaOH twice need N/2. Are you getting that? For BaOH twice, each BaOH twice gives twice 2 OH minus. Total NH plus need NOH minus. So N/2 into 2 OH minus NOH minus. Are you getting that? This way they react. Now BaOH twice, actually what we used is 30 millimole 0.5, 15 millimole. So N/2 is 15 millimole. N/2 is 15 millimole. So ratio is it's written, and HNA is what is written is 0.98. So 0.98 by 98. That means how much? 0.01 and what will be into 100 into 1000. So that means 10 millimole. This is 10 millimole. This is what will be 15 millimole. This is 15 millimole. Okay. So ratio is what? If this is 10, this will be how many times? Ratio 1 is to N/2. 1 is to N/2. So 10 into N/2, which will be equal to 15. So N equal to 3. So it should be tridasic acid. It should be what acid? Tridasic acid. So this is the ratio 1 is to N/2. If this is 10 millimole, this is 10 N/2, which is equal to 15. Are you getting around? 15 given the question. Ninth one, a hydrated salt of MSO4.NH2 undergoes 49.3% of loss in weight and become anhydrous. If atomic weight of the metal is 65, then the value of N, what it is? So the total MSO4.NH2 atomic mass is what? 65. Sulfate will be some 96. That means 161. So 161 plus 80 become 160 into 100. Okay. So 49.3% loss in rate. Now anhydrous salt percentage will become what will be? 49.3 means 50.7. So we are doing this. Because 161 is anhydrous MSO. If we calculate to work out, we will get n. So what is getting n? 8 here. So B. Eight of 7 check. I think I want to give 7 also 8 also. Okay, now some people read 47.3. So 47.3 means 8 will come. 49.3 means 7 only will come. Check the answer. Okay, so you take give mark for about 7 or 8. 10. The volume in ml, 0.1 molar AgNO3 required for complete precipitation of chloride ions. The volume in ml, 0.1 molar AgNO3. Complete precipitation of chloride present in 30 ml of 0.01 m solution. See, this is the coagulation compound. In this, the chloride ion which is there in outside the bracket, that alone ionize. That alone with the silver nitrate will react. That means 1 mole means 2 moles of silver nitrate react and AgCl will precipitate. This will not ionize. The whole thing come out as 1 ion. Okay. So in that case, this is 30 ml into 0.01. So which is 0.3 millimoles. So silver must be 0.6 millimoles. So silver 0.6 equal to its molarity 0.1. So volume must be 6 ml. 6 is the answer. 11th question. 29.2 W by W HCl stock solution. Similarly, this question is about, first you must know initial concentration. Then if you know initial molarity, they want to have some volume you have to take from stock solution. And the final one, to prepare 200 ml 0.4. This is the final one. So you need to find initial molarity. So initial molarity is given 29.2. So HCl 29.2 gram in 100 gram solution. So to find molarity, okay, first number of moles of HCl 29.2 by 36.5. Volume of solution 100 by density 1.25, which is 5 by 4. So 100 into 4 by 5 milliliter. So molarity of the initial solution 39.2 by 36.5. Okay, this is ml. In liters means again divided by 1000. That is 400 by 5000 liters. So 5000 will be one numerator, 400. This is the molarity. So this you should be taken 29.2 into 50 by 36.5 into 4. We do not know volume in milliliter. Final should be 200 into 0.4. So if you work out, you can get 36.5 into 4, you will get what? 73, 146. 146. This can be written 292 into 5 by 146 into V. So this is 2. 2 into 5 what will be? 2 into 5, 10. 10 equal to this side what will be? 8. So V equal to, this is 80, right? 80 by, so 8 and 8 is the answer. So 11th question 8.
Take 49.34 questions, so we get 8.6.
Oh, that itself 8 points. Then 8 only marks. 9th question should be 8. Twelfth one, Mn3O4 become MnO4 2 minus. See here, Mn3O4 become MnO4 2 minus. It must be 3 MnO4 2. So each Mn will be, what is the oxidation state? 8 by 3. So total 3 into 8 by 3 become 3 into plus 6 what will be? 18. So 8 become 18. 8 become, so total how many moles of electrons? 10 moles. So 10 is the end factor, Mn3O4. 13. Ethanol plus iodine plus OH minus CHI3 HCO minus H2O I minus. The coefficient of iodine and OH minus will get balanced. So ethanol CH3, CH2OH. The overall formula we can take it. We can take what will be C2HCOH, we can written as what? C2H6. So C2H6 plus iodine. OH minus will come last. CHI3 plus HCO minus plus I minus H2O common later. Here, carbon, if you see, average what is the oxidation state? 2 plus 6 minus 2. So it is minus average. Average carbon will be minus 2. Here, in one case it will be CHI3. It will become plus 2. In this case it is again plus 2. HCO minus will be like this. Lose 3 electron, gain 1. So this is plus 2. That means both the carbon minus 2 to what will be? Minus 2 to plus 2. 4, 4. Totally 8 moles of electrons. Now you need 4 iodine. In each case iodine here minus 1. Case iodine what will be? Minus. Since already 3 iodine is there, so this has to be 5 because you can't adjust it. If you adjust, then carbon number change, electron will change, everything will change. Are you getting to that? So now as such now it's balanced. Next to charge only. Total what will be? Minus 1. Here what will be? 5 minus 6 minus. So it should be 6 OH minus. Total hydrogen here 12. Here already 1. It is 2, so 5 is 2. So oxygen will be balanced. 5 plus 2, 7. So if you balance stoichiometry, what will be? What they are asking? Iodine and OH minus 4 and 6. B is the answer. Clear or not? You have not done this. Tough, right? It's pretty tough. Guess from correct. Extra iodine remember. 4I2. Yeah, I repeat it. So it is written C2H6O plus iodine gives anyway, people seeing video they go right and do it. So see C2H6O, right? It's carbon, each carbon -2. That is clear? Here carbon is +2, this also +2. So that means -2 to +2, 4. There are 2 carbons, so total 8. Iodine, you see, here also iodine will be -1. When before this putting also -1. So that means 0 to -1. So you need 8 iodine atom. That is 4I2. So satisfied. So 4I2, here already 3 is there. Don't do anything. 2CHI3, if you put it, then carbon change. I minus separate this. So put 5I minus. So balance then charge. Okay. Next. 14. 9 into 10 power minus 3 moles of Xn plus are oxidized to XO3 minus by 6 into 10 power minus. If atomic mass of X is A, then equivalent mass of Xn plus 2. Okay. So let us find the n factor. 9 into 10 power minus 3 into the n factor alone I find it. That many equivalents, because they are doing moles, which is equal to 6 into 10 power minus 3 into dichromate n factor will be 6. So the n factor will be 4. N factor will be 4. N factor 4. N factor only you will decide the equivalent mass. So answer will be what will be A by 4. So you are finding Xn plus equivalent mass. Xn plus, actually the oxidation state will be definitely 1. 1 become 5. So you can't divide by 1. What change transform? Change is +1 to +5. N factor is 4. The n factor only you have to divide, not with the oxidation number. So A is not answer. Okay, A by 4. Right. 15. When BrO3 minus react with the Br minus ion in acidic medium, Br2 liberated. The equivalent mass of Br2. It's like a reaction is comp proportionation. But you have to do the reverse, like a disproportionation. Because you are asking equivalent mass of what will be Br2. So Br2 becoming Br minus. Obviously, same Br2 only undergoes oxidation as well as reduction. So Br2 to Br minus, in factor 2. Br2 become BrO3 minus 0 to 5, so 10 total. By 2 plus 10. So 20 by 12. 5 by 3. That's the n factor. So equivalent mass will be, tell me, 3m by 5. B is the answer. 16. Which of the following is used as primary standard in titration? See, K1O4 definitely can't. Why? Because always contaminant highly react. Okay? With the oxygen itself will react. Na2CO3 dot 10H2O you can use it. As such, anhydrous, if you take it, the anhydrous one will absorb moisture when you are weighing itself. So accurately you can't weigh and prepare the solution. Option C, I already put dot 2H2, crystalline oxalic acid. That means properly we can measure and find its molarity. No, it won't absorb any moisture because already it is 2H2, the crystal. So C is the answer. NaOH obviously deliquescent. If you keep it sometimes, it will melt into a liquid. So while weighing itself, something will melt. Right. Next is 17. The element A forms the acidic oxide with KOH. Element form acidic oxide which reacts with the KOH, forms a salt isomorphous to K2SO4. If the equivalent mass of A 13, then the atomic mass of A. So A, see an element A form acidic oxide which react with the KOH. KOH and reacting with some oxide. Oxide of what will be A and forming what will be K2SO4. I reveal the answer. The element A should be sulfur. And A should be what will be sulfur. I should have given K2AO4. K2AO4 I should have given. Okay. Anyway, I revealed. So the A oxidation state must be what will be +6. Whenever we react with the KOH, acid-base reaction. So AO we do not know some X. Okay. Right? In acid-base reaction, there is no change in oxidation. So this is +6 means that oxide also should be +6. So it could be best, will be AO3 or that oxide. And it's written the equivalent mass of A is what will be 13. Atomic mass must be 13 into 6, but must be 78. That means not sulfur, it is selenium or something. So question, it's what should not be there? K2SO4. Oh, okay, sorry, it's my mistake. Question correct on this. Isomorphous to K. It's not K2SO4. Something. Okay. Could be selenium or something. So our correct answer is what? A. 78. Mass of H2O2 required to decolorize 1 mole of acidified KMnO4. Obviously H2O2 KMnO4 react 5:2. So 2/5. Moles of H2O2 are. The H2O2 means 5/2. So answer C is the answer. Next 90. 0.56 gram limestone was heated with oxalic acid to give calcium oxalate. The precipitate decolorized. 45 ml of 0.2 normal KMnO4 in acidic medium. Calculate the percentage of CaO in limestone. Hello sir. Yeah, tell me sir. Second closer, yes, one flat. Right. 0.56 gram limestone was treated with oxalic acid to give calcium oxalate. The precipitate decolorized. 45 ml of 0.2 normal KMnO4 in acidic medium. Okay. So limestone was treated with oxalic acid. So you will get CaC2O4. So the oxalate only going to react with KMnO4. The precipitate decolorized 45 ml 0.2 normal KMnO4 in acidic medium. So KMnO4 milliequivalents how much? 9 milliequivalents. 9 milliequivalents KMnO4 means 9 milliequivalents what will be